Okay, so let's look at this hypothesis test. And I know you said you got the test statistic, but let's do the whole thing in order to answer all of the questions. All right, so we wish to test the claim that our alternate is true at a significance level of alpha equal 0.005. And we have that the null hypothesis is that the mean is 53.6, and the alternate is that the mean is greater than 53.6. All right. And then let's also notice the sample size is 71, so this will be a large sample hypothesis test. So we'll use our equal norm.inv to do our critical value. Okay, now I've kind of drawn a picture of the normal curve, and notice the alternate is greater than. Okay, so we want for the area that is greater than, that is to the right, to be our critical region, and we want it to have 0.005 in it. So in other words, somewhere over here, I want for this region over here to be 0.005. And I have to find this C value right here for my critical value. Now, when we plug things into Excel or even look things up on a table, it always gives us values based on what's on the left as far as our probabilities are concerned. So since we have right here a critical region where the value is on the right, we need to first subtract that number from 1 to get what's on the left, and then we'll be able to get the correct critical value. So this will be 0.995, I believe. Over here on the left. And so we're going to put 0.995 into Excel and see what Z value we get out. All right, so let me, I don't think I've opened Excel. We'll stop for a minute and get the Excel open. Okay, so here we are. It doesn't matter where we go. Equal, oops, equal norm dot inv, and I think I want SINV 0.995, and I get 2.575829. Now I'm going to write down that whole thing, and that is our critical value. All right, now let's transfer it over here to the picture that I drew, and it will often help you to draw these pictures if you get confused at all. I'm going to erase it, and I'm going to put that number that we got down here. 2.575 829. Now, for the sake of the picture, I really don't need that whole decimal, but okay. Now, anything that is to the right, this is right here, is what we call our rejection region, where the 0.005 was. So anything to the right of 2.575829 will be in the rejection region. That's where we reject the null hypothesis and embrace our alternate. All right, so let's go ahead and do our test statistic. If it's bigger than 2.575829, we'll be able to get rid of our null hypothesis and embrace that alternate hypothesis. All right, so let me go back to wherever I had our picture. Okay, there we go. All right, so we've got our critical value. That's our 2.575. All right, we want to know, and it did say 3 decimal places, so 2.576, I guess, is what I should have rounded that to. So let's get the test statistic, and again, we've got to report it to 3 decimal places. So let me write down all of our information here. Our standard deviation is 20.3. The sample mean is 61.6, and the sample size is 71. And our population mean from our null hypothesis is 53.6. Okay, so let's go over here And we need, first of all, our sample mean, which is 61.6. And then we want to subtract off our population mean from our null hypothesis, 53.6. And that's going to go over our standard deviation, 20.3, divided by the square root of 71. And you can always do this entire calculation right here first and get just your standard deviation of your sampling distribution first. I'm just sticking it in there as that. All right, so let's see. I believe the top is going to give us 8 when we subtract those two. And let me go ahead and put this whole bottom into the calculator. So let's see, that is 2.40917. And then I'll go ahead and complete that division. I get 3.32, and if we round to 3 decimals, 321. All right, now let's go ahead and look back up here at our picture. Let me scroll back up and notice that 3.321 is bigger than 2.576, and so that means it's in our rejection region. If it's in that rejection region, we're going to reject the null hypothesis in favor of the alternate. So let's go back here. It's in the rejection region. The test statistic is in the critical region. All right, so we're going to choose that one. The test statistic leads to a rejection of the null. If it's in the critical region, we reject the null. And our final conclusion is that there is enough evidence to reject the null, or we can say there's enough evidence to support the alternate. So let's see. Sorry, the sample data support the claim that the population mean is greater than 53.6. That would be our correct one right there. Must be the mailman. Hopefully, that helps you through these problems.